Distributed system series. So in this lecture that we will understand how NTP works. The previous part of this video that we understood what is time and how it affects in how it plays a role in a distributed system. Here we will understand how NTP works. NTP, which is called a network time protocol. This protocol is used in This protocol is used to synchronize the time between computers. So we saw that there is no guarantee that we will have a correct time due to the other variable factors such as earth rotation and leap second adjustments. So these are the things that would affect the time in your computer, even if you change the time forward and backward. So in order to properly synchronize the time in our machines, that we can use NTP. So this is NTP daemon is mostly installed in all the operating system, so that it is used to synchronize the time from the NTP server. Let's see how it works. First, let's see your client, and this is, we can call this as an NTP client. So we have servers. We can call this as NTP servers, and we have many stages of servers. It could be, so main thing to understand here is that we have a server, so we can call it as a stratum. This is what is called as a stratum in NTP protocol. So there are servers that are located. This is what zero server, level 0, which means it's a stratum 0. This is where the atomic clock or GPS time source will be used. Here atomic clock will provide the correct time. There are stored in stratum 1, which will get the time from the stratum 0 machines. Stratum 0 machines are most accurate time, since it has a atomic clock and GPS time source. This is a high time precision. That is that this machine keep the time precision very high. So all the other machines that are behind, that are in the other level, such as stratum 1, stratum 2, all the other machines that are located in the stratum 1, stratum 2, so it will get the time from this stratum 0. So it will contact, for example, from the stratum 1, it will get the latest up-to-date time from stratum 0. The same for this one, will get the time from this machine. So or it may contact any machine in the stratum 1 based on the shortest path. It can calculate the path between those machines that are located in the stratum 1, stratum 2. Then it can contact any machines, and finally it will get the most updated time. So how it will get the updated time? Since all these are network of computers, these are connected computers via the network. So whenever we make a request via the UDP, you need a protocol that we can use to update the time source. So there is some kind of network latency we have to consider. So we have to subtract the network latency that is taken to complete the request. So then we can update the time in the local machines. For example, let's say we have a client and we have a server. This is server. Let's call this an NTP server. So this is an NTP server, just for understanding here. So it makes a request So it makes a request to this one and get the response back. Now the time, let's call this is the time is a T0, this is a T1, and this is a T2, and this is a T3. T0 at the time of the request transmission, T1 is at the time of the request packet reception, T2. Once the server once the server processed and send the server time, then it can send it with the server time. For example, here T2. Here when the client receives a T3 is this time that at the time of the request packet reception from the server. Now we have 4 times that we have to calculate the amount of time that is taken to complete the request. Then we will update the local time. So in order to calculate the total time, so for example we are at T0, then we will calculate the amount of time that let's say it's 100 milliseconds. This one is 100 milliseconds, and this one is the processing. Here the client will wait for 50 milliseconds. Here the processing is, let's consider it's at 20 milliseconds. Here it's a 50 milliseconds. So how to calculate the time so that we can move the timestamp to the particular time, so update our local time. So we will first calculate the amount of time T1 minus T0, here 100 milliseconds, then T2 minus T3. Again, let it say it's 100 milliseconds. Here T1 minus T0 and T2 minus T3, 100 plus 100, 200 milliseconds. And if we take the average of it, we will get 100 milliseconds. So then again we will calculate the other time. For example, here we have 50 milliseconds for client to wait, 20 milliseconds for server to process, so 30 milliseconds. So 100 plus 30 milliseconds, for example 130 milliseconds that we have to move the object from T0 to update our time. So this is how it works to update our local time. So we have to calculate the amount of time that is taken to make the request and process the request. Then we will update the time by subtracting the latency, etc. So this is how NTP works, and this is what is called NTP stepping. So we move the time forward or backward based on the time that it is provided by the server. This is what is called NTP stepping. Why it is important? Why it is important? Because server in a distributed system, when multiple machines are connected, when multiple machines are connected, they all have to synchronize the time from NTP. So we have 3 machines that are connected, but whether we can say that, for example, we are sending a message M1 to this machine M2. Message is stored here M1 as M2 with the timestamp. So since timestamp is synchronized, time is synchronized from the NTP. So which one is stored first and second? We cannot say that M1 is stored first, M2 is stored second. Some cases, there will be cases that time, this will be a lesser time compared to this one due to NTP stepping up in current clock. So even though we may use NTP, in some cases we not get the correct timestamp. In a distributed system, we cannot completely rely on timestamp. So that the next section that we will see how to use the other clock. So far we discussed the physical clock. Next section we will discuss about the logical clock that is based on counter. How we can use this in a distributed system to order the messages that are stored in the distributed system, so we can order them with the clock called logical clock.